Hello, I'm Roman, and welcome back to a series of videos Neural Networks from Scratch in Go, where we using this book, Neural Networks from Scratch in Python, but writing everything with the Golang. And in the previous video, I almost finished with the new implementation of the new loss functions. I implemented the mean squared error, took a look at the next one as mean absolute error loss, and I decided to leave implementation for today so I can, just follow the process and start from it. It's usually easier to start from something that you already know how to start rather than, starting from something absolutely new. Yeah. Mean absolute error loss. And the reason that it will be pretty much the same. Um, mean absolute error loss. It will be very different, or it will be pretty much, well, not pretty much the same. What's the word? I mean, the difference between them will be not that big because, for example, well, the calculate method is the same. The forward methods, instead of squaring the difference, we will use the what's called ABS, the absolute difference between them. That's it. With the backwards, I think that will be a little bit different. Same. So here we need to return 1 or 0, or 1 or minus 1, based on the result. So if we take a look, returns an element-wise indication of the sign. So if it returns -1, if the expression is 0, otherwise it returns, well, it returns 0 if the x is 0, it returns 1 if the expression is non-negative, right? So, and 0 if parameter. Yeah. So the first question is, do I have something like this? Maybe in, no, not. Okay, I will implement here sign. I think I can pass the function, right? Oh, no, okay. Value value float 4, and it returns int value. And the code is simple. So if the value is less than 0, return -1, else if value equals to 0, return 0, else return 1. That's it. So then we're changing this one. So what do we need to return? We need to return the sign for the expression. So sign, what we, true value minus d value. So target minus target minus so d value and then divided by outputs and the samples, divided by outputs count and divided by the sample count. Okay. Since I'm using it only here, I will use it will return the float 64. So right now, we need to change the regression. Well, how we calculate the accuracy, because previously we had predictions of the concrete, what to call it. So for example, in the binary classifier, it was true or false. In the category, we predicted a concrete class. But right now we'll have two floating point values. I think it should be simpler to write the accuracy for regression. I assume it will be, well, actual difference between the predictions, like the predicted value and the true value. And we just calculate the difference. Maybe I'm wrong. But maybe I'm wrong that I'm wrong. Let's see. Now that we got our data and activation function and the loss calculation for regression, I would like to measure performance. With cross entropy, we were able to count the number of matches and then divide by the number of the samples to measure the model's accuracy. With the regression model, we have two problems. The first problem is that each output neuron in the model, there might be many, is a separate output. Like in a binary regression model and unlike in a classifier where all outputs contribute towards a common prediction. Yeah. The second problem is that the prediction is a float value, and we can't simply check if the output value equals to the ground truth, and it's most likely won't. If it differs even slightly, the accuracy will be 0. Well, if we compare it strictly, then yes. For example, if your model predicts home prices and one of the samples has a target price of this and then predicted this one, then a pure is it equal assessment would return false. We would likely consider the predicted price to be correct or close enough in this scenario with given the magnitude of the numbers in consideration. There is no perfect way to show accuracy with regression, still it's preferred to have some accuracy metric. Okay. For example, Keras, a popular deep learning framework, shows both accuracy and loss for regression models, and we will also make our own accuracy metric. First, we need some limit value, which we'll call precision. To calculate precision, we'll calculate the standard deviation from the ground truth target values and then divide it by 250. This value can certainly vary depending on your task. The large number you divide by, the more strict the accuracy will be the metric. 250 in our code of choice codes, okay, the accuracy, standard deviation from the ground truth. Then we could use this precision value as a sort of the cushion allowance for regression outputs when comparing targets and predicted values for accuracy. We perform the comparison by applying the absolute value on the difference between the ground truths and the predictions. Then we check if the difference is smaller than our previously calculated precision. And then we take the average. I'm more interested in this actually. Compute the standard deviation along the specified axis. Return the standard deviation a measure of spread of the distribution of the array element. the standard deviation is computed for the flattened array by default, otherwise over the specified axis. Okay, so the question is, do I have it? Sample, mean, and unbiased standard deviation. Yeah, I guess I need to use this one. Where it comes, it's from go_num_stat. And actually, I think that's in the accuracy. Calculate binary. Calculate prediction. It's not the target, it will be target values, right? And it returns the accuracy. Okay, assume predictions are 1D array. So I need to calculate the precision. So precision, always have troubles writing this word. Okay, I need to stat standard deviation. No, wait, not this one. And then what is X? It should be predictions row and an empty one. Or can I nil? Okay. And then I have the precision and it should be divided by something. Then I'm taking, well, have the predictions. Predictions, which is the predictions data. Then we need to calculate the accuracy. Absolute. So we calculate in the absolute. And okay, then we use count. I will explain mine because we'll return count divided by count divided by len predictions. Right? Right. So then for, do I need, yes, and in range breadths, what do? We need to check if math absolute value between predicted and target value is less than precision, then we count it. Okay. And that's it. Okay, so right now we can go and create the new model. We have the regression. Okay, that's purely empty. Okay, we have X and Y. We're taking it from data set. assign data. How many samples? Okay, one. Let's do it 1000. Do I have it open? Yes, 1000. Then we have layers calculation. We have dense layer 1, dense 1. Number of inputs should be 1 and 64 neurons, right? Right. Then we have activation, which is the activation rel, I think. Mm, Activation, okay. Create second dense layer with the 64 input features as we take out our previous and one output layer. Yeah. We have second layer and tends to we'll have 64 inputs and one output. Then we should have the second activation, which in this case I think will be linear. That basically does nothing. And then we have loss function that loss. Which one we're going to use? Squared mean, squared error, and optimizer equal to optimizer new Adam, I think. New Adam. Accuracy precision for there are no really accuracy factor for regression model, but we can simulate approximate it. We'll calculate it by checking how many values have a difference to the ground truth equivalent less than given precision. We'll calculate this precision as a fraction of a standard deviation. Okay. Okay. Then we go into, can I do something for range? Cannot range. No. Okay. Or I mean, I still need the epochs, right? Okay. Okay, let's go dense one. Forward takes X. Activation one forward that takes dense one output. Then we have dense two forward that takes activation one output. We have the second activation forward that takes dense two output, right? And then we need data loss, activation two. Okay, then we have data loss, that is loss function. Calculate. Predictions. Take the activation two outputs and the target values. Mm, I will have this number, one column and X. Okay. Then I need Data loss, regularization loss, and loss value. Then I need to have accuracy, which will be accuracy this one. Predictions we will take from the last activation and then y, right? Okay. Then of course this one. In I think I can even copy this. Where is it? Okay. What we have? Loss function backwards. Activation to outputs target. Right. Activation to output. Then we actually go into activation to backwards and we take d values from the loss function output. No, d inputs. D inputs. What's going on? D inputs. This. Optimize. Dance 2, backward, activation 2, the inputs, activation 1, here takes dance 2, and this one, right? From dance 1, activation into dance 2, dance 2 into second activation into the loss function. Okay. And of course we need an optimizer. Let's optimizer. Okay, this is the training process, right? Training didn't work out very well. Let's add an ability to draw the testing data, and let's also do a forward path on the testing data. Drawing output data. Okay. Very, very small accuracy. Loss is kind of the same. Okay. Training didn't work out here well. Let's add an ability to draw the testing data, and let's also do a forward path on the testing data drawing output on the same plot as well. X y test and testing data. Okay. X test y test equals to data set 9 data another 110 test data needs new dense one test. Okay. Then doing a empty print when testing run. Oops. Basically, I'm doing this. Instead, test data. Plot. Well, I don't have the same. Oh, it's called scatter sign data. Well, I guess I can do this. And I think that should be then or how to call it sets. Okay, equals to 0. It's less than len of x plus plus. Then move this one, right? Then we have j len of x. And then we do this. How I can plot it? I need to form okay, xx equals to make plot 64 2. Same plot 64 2. Okay, I will do it in a hacky way, but this, and I do this, and then y, then xx 0. Maybe I didn't have to make it actually, because I can do x, right? Here I can do x test, and this I can do y, and here it will be y, right? And I can scatter sign data xx or y. Maybe I have the range testing data. Okay, I will quickly check it and continue tomorrow. Oh, I need to wait. Yeah, almost finished. Okay. They're the same. All right. Yeah, yes, of course. I mean, there should be the activation to results, activation to out, not date, this one. Okay, let's try again. Yeah, I've been plotting the same data. I forgot that this one is not. mm, This one is not random. Oh, okay. Okay, so on this interesting note, yeah, I actually have pretty much the same line. On this interesting note, I will stop for today and I will continue tomorrow to figuring out why the hell it doesn't work. Thank you for watching and I see you tomorrow. Bye bye.